In this video, we will work on all of the concepts that we have learned in the triangles unit. So let's review a couple of rules. For me to be able to use law of sines, I need to have an angle and an opposite side given. So usually if I have an AAS or an angle side angle, this is when I use law of sines. When I'm given something like SSA, I use law of sine as well, but here you have to be careful. Sometimes we might have only one triangle. Sometimes we might have 0 triangles, and sometimes you might have 2 triangles. So you need to be careful when you have the ambiguous case. Now, as for law of cosine help you find sides. So basically, most of the sides should be given for you to be able to use law of cosine. So for example, if you have side, angle, side, or side, 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 this is when law of cosine is easy to use. Now, law of cosine is basically the side squared is equal to the other side squared plus the third side squared minus 2 times b times c cosine of the angle A. That's the law of cosine. Now, law of sine is if you have a sine of an angle over the opposite side is equal to sine of B, angle B, over the opposite side B is equal to sine of angle C over C. Now, let's talk more about the ambiguous case. Every single time you have an angle given, let's say this is angle A, and an opposite side given, which is, let's say, A in this case, and side B is given. So basically, you need to compare the opposite side to the adjacent side. If the opposite side is greater than B, which is the adjacent side, then I have only one triangle. If A is less than B, then you have to find the height. Drop a height from C. If A, so that's the first thing, is that if A is greater than B, then that's one triangle. If A is less than B, then we have two cases in this case. If A is greater than H, but less than B, that means I have two triangles. If A is less than H, then I have 0 triangles. Let's talk more about the two triangles. If I have an angle, an opposite side that is smaller than B but bigger than the height, that means this triangle can be drawn in two different ways. That could be my first triangle, or then this could be my other A, and that would be my second triangle. So in this case, you have two triangles. This triangle over here and the green one. Now, the nice thing about the obtuse triangle is that this angle over here and this angle over here are supplementary. So if I know this angle, I do 180 minus that angle to find the obtuse angle. So this way it will be easier to solve this triangle. Now, what if, so third case, what if A is equal to H? Then in this case, I have a special triangle, which is the right triangle. The A is actually the height, so then I have one triangle. So this is like a quick review of the ambiguous case. We might have one triangle, we might have two triangles, or we might have 0 triangles, depending on the, as you compare the opposite side to the adjacent side. Remember, if A is less than B, this is where you need to find the height. Okay? Now, once you find the height and decide whether you have 2 triangles or 0 triangles or 1 triangle, then the height does not go into the calculation anymore. The height just helps you determine how many triangles you have. Okay, now we're ready to start on number 1. So first of all, I need to decide what is given. So I am given, let me sketch triangle ABC. I am given side A to be 79 degrees. I'm given angle A to be 79 degrees. I'm given angle B to be 33 degrees, and I'm given side A to be 7. Okay, so I have A, S. So I use law of sines. And besides, whenever you have an angle and an opposite side given, this is when you use law of sine. They want me to solve all of the triangles, so I'm going to start with that. So sine of 79 over 7 is equal to sine of 33 over B. So B is equal to 7 times sine 33 over sine 79. So you can cross multiply. So it's going to be 7 times sine 33 over sine 79. Now use the calculator to find that. You can put it all in one step. Now since they did not tell me how to round, so alpha y equals enter, I'm going to put 7 sine of 33 over sine of 79. And that will give me, since they did not tell me how to round, I'm going to round everything to the third decimal place. So 3.88. So I had A equals 7, B equals 3.88. Okay, I still need C. I know angle A is 77 degrees. Angle B is 33. And I can find angle C since it's 180 minus angle A minus angle B. So that's 68 degrees. Now to find angle or side C, I'm going to do sine of 68 over C is equal to sine of 79 over 7. So again, C is equal to 7 sine of 68 over sine of 79. Now put that in the calculator in one step. So alpha y equals, enter, 7 times sine 68 sine 79. And that would give me 6.612 6.612. So these are all of the sides and all of the angles. Now let's move on to number 2. I'm given 3 different sides, so side, side, side. Every time you are given side, 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 first of all check, is this a triangle? Remember, the sum of any 2 sides should be bigger than the third side. So in this case, 5 plus 7 is 12, which is bigger than 6. 6 plus 7 is 13, which is bigger than 5, and so on. So yes, I do have a triangle. So I have side, 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 so I use law of cosine to help me determine all of the angles. So I'm going to start with A. So A squared is equal to B squared plus C squared minus 2 times times B times C, cosine angle A, which is what I want. Now to find A, I need to isolate the angle. So A is going to be inverse cosine of 7 squared plus 6 squared minus 5 squared over 2 times 7 times 6. So I put that in one step. So second cosine, alpha y equals to give me a fraction. And I do 7 to the power 2 plus 6 squared minus 5 squared over 2 times 7 times 6. I close parentheses, press enter. So I get the angle A to be 44.415 degrees. Again, they did not tell me where to round to, so I'm going to round to the third decimal place. So if I want to find B, B is going to be the inverse cosine of 5 squared plus 6 squared. So that's the A squared and the C squared minus B squared over 2 times 5 times 6. Now put that in the calculator and tell me what you get. So that will give me 78 180.463 degrees. Now to find angle C, I simply subtract 180 minus angle A minus measurement of angle B, and that will give me for C 57.122 degrees. So let's see what we have so far. We did number 1, it was AAS, and we used law of sine. We looked at number 2, we saw SSS. So the first thing I need to decide whether I have a triangle or not before I can use law of cosine, which I did, and I was able to find all 3 angles. Now let's move on to number 3. So in number 3, I have angle B, which is 28 degrees. The opposite side is 10, and the adjacent side is 12. So I'm given an SSA, so that is the ambiguous case. So first of all, before I decide to use law of sine, I need to know how many triangles I have, or maybe if I have a triangle to start with. So you see that the opposite side is less than the adjacent side. So first of all, I need to check, is it bigger than the height? Because if it's smaller than the height, then I do not have a triangle. So we have to find the height. So sine of 28 in this right triangle over here is opposite over hypotenuse. So h is 12 sine 28, which is 5.634. So the opposite side, B in this case, is between 12 and the height. So yes, I do have 2 triangles in this case. The first triangle is the triangle that you see in front of you, the acute triangle. It would be helpful if I can draw a somehow straight side. Okay, so that's 10, that's 12, and that's 28. So I decided that there are 2 triangles, and that's the first triangle. It's the acute triangle. So let's find all of the angles and the sides. So let's start with angle A. So sine of angle A over 12 is equal to sine of 28 over 10. So angle A is going to be the inverse sine of 12 sine 28 over 10. So remember, every time you're trying to find an angle, you're doing the inverse sine. So put that in the calculator, do inverse sine, and let's see what we'll get. So inverse sine, alpha y equals to give me a fraction, and then 12 sine of 28 over 10, and that gives me 34.289 degrees. So I just found angle A. Now to find angle C, you do 180 minus angle A minus angle B, and that gives me 117.711 degrees. So C is 117.711 degrees. Now we still need side C, so I'm going to use law of sine again to help me find C. So sine of angle C over side C is equal to sine of angle 28 over the opposite side, which is 10. So C is what I want, and angle C, I know it, I just found it, it's 117.711. Okay, so C is equal to 10 times sine 117.711 over sine 28, which, if you put it in the calculator, that's going to give you 18.857. So that is the side. So we're able to find all 3 sides and all 3 angles. So let's write them down. A is 12, B is 10, and C is 18.857. Angle A is 34.289 degrees. Angle B is 28 degrees, and angle C is 117.711 degrees. So these are all the sides and all the angles. Now, remember, we just found one of the triangles. I do have another triangle. It's the obtuse one. So that's going to be this triangle over here. So that's going to be B, A prime, C prime. So the previous A was 34.289. So to find this A, I do 180 minus the measurement of angle A. So 180 minus 34.289, and that's going to give me 145.711 degrees. Now to find C prime, I simply do 180 minus the measurement of angle B, which is 28, minus the new measurement of A, 145.711, and that's going to give me 6.289 degrees. Now the measurement of side A is not going to change, it's 12. And the measurement of the measurement of side B in front of angle B is not going to change, it's 10. So there is a new measurement for C. In order to find that, we can do law of sines. So law of sines is going to give me sine of 6.289 over C is equal to sine of angle B, which is 28, over 10. So to find C, I cross multiply, and I find C to be 2.333. Now go ahead, pause the video and try number 4 on your own. Now for number 4, you will find that angle A is equal to 34 degrees, angle B is 74 degrees, and angle C is going to be 72 degrees. Side A is 2.940, side B is 5.054, and side C is 5. So this way we have solved all the angles and all the sides. Now let's move on to number 5. So number 5, I'm given 3 sides, and remember what we said? Every time we have 3 sides, we have to check if the triangle exists to start with. So 6 plus 7 is 13, which is equal to A. That is not possible, so there is no triangle formed for this case. Remember, the sum of any 2 sides should be greater than, not equal, just greater than the measurement of the third side. Now let's move on to number 6. I am given a side, and angle, so let's see where the angle goes in this case. So if this is angle B, then the side in front of it is going to be side B. And if this is angle A, then the side in front of it is going to be 8. And this is 3. Now, you see how the opposite side is smaller than the adjacent side? So B has to be greater than H, or equal, for this triangle to exist. So every time the opposite side is less than the adjacent, I have to find the height. So sine of 30 is equal to height over hypotenuse. So H is going to be 8 times sine 30, which is 4. So you see how side B is less than the height? So that's not possible. So then basically this side doesn't even touch A. So remember, the shortest distance between a point and a line is the perpendicular. So I cannot have a side of a triangle or a side that is shorter than the height, then it will not touch the angle A. So in this case, this triangle does not exist. Now let's move on to number 7. Now in number 7, I have side A. So let's say that this is angle A, so this is 4, this is angle B, so this is 5, and this is angle C, so that's 30 degrees. So I'm given side, angle, side. Now let's go ahead and find some of the other measurements. Now I need side AB. So since this is SAS, I'm going to use law of cosine to find the opposite side. So let's say that this is C, so C squared is equal to 4 squared plus 5 squared minus 2 times 4 times 5 cosine angle 30. So C is going to be 2.522. Now remember, whenever I have law of cosine, I need to make sure that I find the sides in order, or the angles in order. I always use law of cosine to find the measurement of the largest angle. So if I want to find either A or B, I have to find B first, because angle B is in front of the longest side, so that is the largest angle, so I need to find that first. So then 5 squared equals 4 squared plus 2.522 squared minus 2 times 4 times 2.522 cosine of angle B. So to find the angle B, I need to do inverse cosine of 4 squared plus 2.522 squared minus 5 squared over 2 times 4 times 2.522. So put that in the calculator, and you'll find that angle B is equal to 95.517. So we just found the largest angle B using law of cosine. To find A, I simply subtract measurement of angle B and measurement of angle C from 180, and I get angle A to be 52.483 degrees. So I just found angle A, angle B, and side C. Now let's move on to number 8. In number 8, I am given side A, which is 16, side B, which is 19, and angle C, which is 112 degrees. So this is SAS. I'm going to use law of cosine to help me find the measurement of the side that's missing. So C squared is equal to 19 squared plus 16 squared minus 2 times 19 times 16 cosine angle 112. So C is going to be 29.065. That's the missing side. Now, moving forward, I see that 112 is the largest angle. A and B must be smaller than this angle. Remember, even if this is SAS and I started with law of cosine, I always use law of sine to find the smallest angle. Since the largest angle is given, what I'm going to do is I'm going to find side or angle A, which is the smallest angle, using law of sine for my answer to be accurate. So using law of sine, I can find sine of A over 16 equals sine of 112 over 29.065. So remember, I use law of cosine to find the measurement of the largest angle if I'm given SAS, and even if I'm given SAS, but the largest angle is given, I need to find the smallest angle. I use law of sine. So law of sine to find the smallest angle, and law of cosine to find the largest angle. So in this case, A is the inverse of 16 times sine of 112 divided by 29.065. So angle A is going to be 30.691 degrees. And to find B, I simply subtract the measurement of angle A and measurement of angle C from 180, and that's 37.309 degrees. Now let's move on to number 9 and 10, where I'm required to find the area of the triangle. So if I look at this triangle, I see that all three sides are given. So let me first of all check that this triangle exists. The sum of any two sides is larger than the measurement of the third side, so then we're good. So remember, I can use Heron's formula to find that, which is to find the area is equal to the square root of s times s minus a times s minus b times s minus c. I do this formula or use this formula when I'm given side, side, side. So s is half of the perimeter. So it's half the sum of 3 plus 5 plus 6, and that's equal to 7. So the area is going to be 7, 7 minus 3, 7 minus 5, and 7 minus 6. And the area will end up being the square root of 56 units squared. Now let's move on to number 10. In number 10, I'm given an angle A, an angle B, and the measurement of side C. Now, I know another formula, but that only applies if I have SAS, which is the area is equal to the measurement of side A, let's say, side B, sine the angle between them, over 2. So I need an SAS to be able to find the area of this triangle. So first of all, I either need to find side B or side A to be able to find the area of this triangle. So let's find side B. I can do that using law of sine. So sine of 74 over B equal sine of C over 5, which is C is somewhere I can find, something I can find, because 180 minus 74 minus 34, that's going to give me 72 degrees. So now I know angle C, which is 72 degrees. So B is, I cross multiply and find B, and I find it to be 5.5, 5.054. So then the area is going to be side B times side C sine the angle A between them over 2. So that's going to be 5 times 5.054 sine of 34 over 2. And the area would be, in this case, 7.065 units squared. Now remember, you will get the same exact answer if you chose to find side A, because side A and side C and the angle between them would be given in that case, and then you can find the area. So that's the front page of the review. Okay, let's start with word problems. You are standing atop a 1,000-foot cliff. So let's say that this cliff is 1,000 feet long. So I'm standing over here. And you look up across the far ridge at an angle of elevation of 10 degrees. So then you look up with an angle of elevation of 10 degrees. You look down to the bottom of the far ridge at the angle of depression of 50, and you look down to the bottom with its angle of elevation of 50. So basically, you're looking up with an angle of elevation of 10 and down with an angle of elevation of 50. So this cliff, whatever it is, probably they're going to ask me to find how much this whole thing is. So let's keep reading. How tall is the other ridge? Ignore your height. So basically, I'm standing over here. I'm looking up. Remember, the angle of elevation is with the horizontal to the top of the ridge. And then I'm looking down to the bottom of the ridge with an angle of depression of 50. And they want me to find this side. Now, remember that this is 90 degrees. This is like a height. So what I can do is, let's see, how long is this thing? This is 1,000. So then that means that this is going to be 1,000. So what I can do is use this right triangle. I have an angle I have the opposite side. I need the adjacent side because when I have this side and this angle, I can use this triangle. So let's use first this triangle, this right triangle over here. Sine of, or tangent of 50 is opposite over adjacent. So let's call this y. So tangent of 50 is the opposite side, which is 1,000, over the adjacent side, which is y. So y is 1,000 divided by tangent 50. And that will give me 839.0996. So I just found this side over here. Now what I'm going to do is take this right triangle over here, and I know the angle, I need the opposite side, and I have the adjacent side y. So let's use SOHCAHTOA. Tangent of 10 is equal to the opposite side, so let's call this z, over the adjacent side, which is all this. So z is going to be equal to tangent 10 times 839.0996, and z in this case will be 147.956. So x is going to be 1,000 plus z, this whole thing over here. So that would give me 1,147.956 feet. And that's the length of the ridge. This is how tall the ridge is. Now let's move on to number 20. Two ships leave the same port on courses that diverge at an angle of 52 degrees. So one ship is going in this direction, and the other is going in the other direction, and they make an angle of 52 degrees. At speeds of 12 miles per hour and 30 miles per hour respectively. Now remember that distance equals speed times time. So I know the speed for each one, and I know the time because they want me to know how far these are in 2 hours, so that the time is 2. So in order to find the distance covered by the first ship, I do the distance. So I multiply the speed of the first ship times 2, and that's going to give me 24. And the other one is 30 times 2, that's 60. So I have two sides, included angle. I can use law of cosine to find this side. So c squared is equal to 24 squared plus 60 squared minus 2 times 24 times 60, cosine the angle between them. So side C in this case is going to be equal to 49.019 meters, or miles, since they said miles per hour. Now what is the area of the ocean they have triangulated? So I have a side angle side, so I can do 24 times 60 times sine of the angle between them over 2, and that will give me the area. So the area is going to be equal to 567.368 meters squared. Now let's move on to the next problem, which is problem 13. 3 radio masts K, W, and P are situated in the Australian outback. K is 250 kilometers due south from W. So from W going south 250 kilometers. W is 410 kilometers from P. P is of bearing 130 from K. So from K, you're drawing in north, and then this is 130 degrees from K. Calculate the bearing of P from W. So basically, they're asking, from W, what is this angle? What's the bearing? So then what you do is, if they didn't graph it for you, or they did not draw the triangle for you, from W, you sketch the north, and then this is the angle you're interested in if they want the bearing of P from W. That's the unknown. So to find that, I need to know what this angle is. because if I know this angle, what this angle is going to be 180 minus that angle. So let's see what I have. I have an angle, I have a side, I have a side. So what I can do is use law of sine. So sine of P divided by 250 is equal to sine of 130 divided by 410. So the idea is to find P, and once I find P, I will know this angle, which is, let's call it Y, because these three angles will add up to give you 180. So P in this case is equal to 27.846 degrees. So angle Y is going to be 22.154 degrees. Now remember, to find x, you simply subtract y from 180. And that's going to give you 157.846 degrees. Okay, let's move on to 14. A ship sails from Harbor H on a bearing of 84 degrees for 340 kilometers until it reaches point P. It then sails at a bearing of 210 degrees for 160 kilometers until it reaches Q. Calculate the distance between Q and the harbor. So this is what they want. So if you look at this triangle, I only have two sides. Probably if I find this angle, that's going to be extremely helpful. So what can we do? If you look at angle H and angle P, these are supplementary because they are the same side interior. Do you see how these two lines are parallel? So 84 plus P, that's going to give you 180. So 180 minus 84, that's going to be 96 degrees. Now, this whole thing over here is 360. So if I know that this is 96 and this is 210, I subtract those two from 360 and I get 54 degrees. So I have an SAS now, so I use law of cosine to find the missing value. Minus 2 times 340 times 160. Cosine the angle between them, and that's going to give me 277.937 kilometers.